Okay, in this part of the lesson, we're going to be working with ordering scientific notation. So the key thing is first of all of your numbers have to be in proper scientific notation. That's where we have one number to the left or in front of the decimal, and the number is multiplied by a power of 10. Okay, so once they're in proper scientific notation, the first thing that I recommend is looking at your exponent numbers. So if your exponent numbers are not the same, the larger the exponent, the more it is worth, because it's going to have more place value, okay? In the case that we see right now on our screen, if they have the same exponent, then we're going to go ahead and compare the front numbers. So when I'm looking at this example on the screen, I'm going to first look at my exponents. 8, 8, 8. And I kind of did this in a previous lesson, but we were really kind of trying to decide which was bigger. Here we're going to put them all in order. Okay, so those are all the same. So since they're all the same, we're now going to compare the front numbers. So if you are not comfortable with decimals, one thing you can do is make sure they have the same number of places. So if I want to make sure that they all have two numbers behind or to the right of the decimal, I could add a 0 to this. Okay, now I'm going to compare 1.20, 1.19, 1.12, okay? And yes, I could read that in proper form, but many of you maybe are not comfortable with decimals, so you can really compare the 20, the 19, and the 12 because they are all in the same form. They have the same number of places. So what's the smallest? The 12. So my first answer, if I go smallest to largest, would be 1.12 times 10 to the 8. That's my smallest. That one's done. Then 19 would come. So 1.19 times 10 to the 8. And then finally my 1.2. 1.2 times 10 to the 8. Most common made mistake is kids think because this really only had one number behind it, it's worth less. No, remember, once you're in decimal form, you're working with the place value, and that's really 2/10, whereas this is 1900ths and 1200ths, okay? All right, so let's try some more of these. So first thing, look at your exponent. If they're all the same, then you're gonna compare the front numbers. So let's look at these exponents, okay? So we're gonna compare, are the exponents the same? No. So we don't even have to, if we look, the front numbers are all the same, but we wouldn't, even if they were different, our exponent's gonna tell us. Now we have to remember, we are working negatives. So remember that negatives is the same as saying the opposite. We have to think the opposite, okay? So normally we would say the bigger the number, the more it's worth. Well, we're working opposite because we're working negatives. So the bigger the digit behind that negative sign, the less it's worth. So if I'm gonna do smallest to largest, this one here is my smallest because it has a -8. So 4.8 times 10 to the -8. Well then, which one would be the bigger number between -6 and -5? Well, you would think 6 is bigger, so we're doing opposite, so it's really smaller. So then I would say 4.8 times 10 to the -6, and then 4.8 times 10 to the -5. Now some kids will go through and actually convert these to standard form. To me, that's more work. Look at your exponents. If they're different, then you're gonna put the exponents in order. If they're the same, then you're gonna compare the front numbers and put them in order from that. So exponent is always your first step to look at. Look at that exponent first. Okay. So here we're working with, wow, now they've given us some percentages, some fractions. They're kind of tying it all in together. So what we want to do is get these all into the same type of format, okay? So I'm going to convert them all to a decimal form first, okay? So I'm going to convert this percent to a decimal. So to change from a percent, I want to move away from the percent sign 2 places. So 1, 2. So this one's 0.63. Okay, this one, I could change it to scientific notation or to standard form, which is what I'm gonna do because I'm gonna have these in standard form, so I wanna change this to standard form. So I'm gonna go -3 places. So negative is that way on the number line. So 1, 2, 3, so 0.00625. This would be 6 1/4, 1 divided by 4 is 0.25. And then this is 0.625. Okay, so let's look. I can identify right away my largest, super easy. This is my largest. It's all the others have zeros in front. If I didn't put anything, it means it's a 0. So 6 1/4 is my largest. And I'm going back and writing it in its original form. Okay, so this one's done. So now let's look. Okay, I have a 0, and a 6. Ooh, I'm gonna go ahead and do this one. That's my third largest, so I'm gonna write that here. So 0.625 was that one, down looking. So now I'm comparing these, okay? I have a 6 and I have a 0. Well, 6 is bigger, so that's my next one if I'm working backwards. And that was originally 6.3%. And then my last one, this is my smallest here. So the original was 6.25 times 10 to the -3. That one's really tricky. You have to take your time. You have to get them all into the same format. I personally like standard form, but you can convert them all to scientific notation if you want. But here it would be converting 3 of them into scientific notation versus a couple of them into their standard decimal form. Okay? All right. Okay, so I want you guys to go ahead, pause your video, test this one out. I want you to go through, put these in order from least to greatest. Okay, so if you want to do a 1, 2, 3, you can do that, or you can actually write them out. So go ahead, pause your video and work your way through these. Okay, or this was 1, 2, 3 if you were going least to greatest. Okay, once again, as you're working through these, your first step needs to be look at the exponent. If they're all the same, then you're going to look at the front numbers. Okay, if your exponents are different, the larger the exponent, the more it's worth.